Okay, today in lesson 6.4 we will be comparing linear and nonlinear functions. We know that the graph of a linear function shows a constant rate of change. The constant rate of change in a linear function, remember that a linear function would be a straight line, okay? A linear function can be written in the form y is equal to mx plus b, and the constant rate of change is equal to the slope. A nonlinear function, however, does not have a constant rate of change, so its graph is not a line. Some examples: you could have a curved line. You could have a wave line, or you could have a bunch of jagged lines, right? But the whole function that produces each one of these graphs would be considered nonlinear. So we want to know, looking at a table or a graph, if it represents a linear or nonlinear function, and then we need to explain. So one thing we might need to do is determine from a table, could we put it into slope-intercept form? Could we write a function rule? Okay, so when you look at the change in y, it is going down by 5, and each of these changes is the same, okay? Looking at the x, the change in the input is an increase in 7. So as the input increases by 7, the output decreases by 5. Your slope, which is change in y, it's important that you put the top number correctly. This negative 5/7. We could even write the function rule because we see the y-intercept of 25. So we could have y is equal to negative 5/7 x plus 25. But more importantly, we need to be able to just say that this is linear. And we know this because there is a constant rate of change. We know that from the slope. Okay. Looking at the next one, number 2. Going from 8 to 4 is taking away 4 or subtracting 4. 4 to 0, subtracting 4. 0 to negative 4, again subtracting 4. 2 to 4 is adding 2, and these are all adding 2. So your slope is equal to negative 4/2, which can simplify to negative 2. So since there is a constant rate of change, we could then calculate or determine what the constant or the function rule is, but you're not needed to do that right now. You just need to say that this would be linear because of the constant rate of change. Okay, so looking at number 3, we need to determine if it's linear or nonlinear. Now remember, if it's linear, the slope would be the same throughout. I could tell that for this part of the line, there's a positive slope. For this part of the line is a negative slope. Therefore, it does not have a constant rate of change. Something happens within this function. So, we would say it is non-linear. The graph is not a straight line. Okay. And there is not a constant rate of change. It does not have the same slope throughout. So that's going to be one thing that will help determine if it's linear or nonlinear. We want want to know if the equation would represent a linear or nonlinear function. If linear, it could be written in slope-intercept form. Remember, slope-intercept form, y is equal to mx plus b. Equation 4 is exactly in that order. Therefore, it's linear because you can write it in slope-intercept form. Looking at 5, y is equal to 4x over 3. Well, that 4 over 3 is like a fraction. We could rewrite this and say 4 over 3x. That would be having a y-intercept of 0, but it is in sloped-intercept form, so it is again linear. Even if we rearrange the terms here and write negative x squared and this positive 1, because of the exponent of 2, remember your slope component cannot be squared. When you have something squared, it will not be at a constant rate of change. So this is a non-linear because it cannot be written in slope-intercept form. All right, and notice that the x in slope-intercept form has an exponent of 1. Anything with an exponent greater than 1 is a nonlinear function. So let's give a couple of these a try. If you're asked to graph the data in the table and then decide if it is linear or nonlinear, okay, I'll make some thicker marks here. So we would have -2, +4. We would have 0, 0. We would have 2, 4. And we would have 4, 16, which would be way somewhere off the charts. Okay, so because the line does not have the same slope, right? Negative then positive, we would say nonlinear. Okay, looking at the next one. -1, -1, 0, 1, 1, 3, and 2, 5. Because these dots or these fall into a straight line, right? You could write a rule for it that would be in slope-intercept form. It is a linear function. Okay, looking at 3 and 4, does the graph represent a linear or nonlinear function? For number 3, it's linear. We have a straight line. It has a constant rate of change. And this would be nonlinear. Hopefully you're picking this up right now and understanding, because we go from a negative slope to a positive slope. It is not a constant rate of change. This is not one continual line. All right, looking at the table. So we have our input. Our input is increasing by 1 every time. Our output goes up by 4. Then from 4 to 9 goes up by 5. And then up by 7. So looking at how this changes, the output values are changing. We can't find a pattern or a slope. So we wanted to know if it was linear or nonlinear. Well, it is non-linear. There is not a constant rate of change.